So in this second pencast, we want to talk about some facts of exponents and then see how exponents work if we have a fractional base. So we're going to start with the facts about exponents. And our first fact is that any base raised to the power of 0 is equal to 1. Now, this means that any base, and so I just use n to represent any number. So any base raised to the power of 0 is 1. It's an odd fact, and we would really need algebra to be able to prove it. So right now, we're just going to use it as a fact. So I've got a few examples down here. My first example says 2 to the power of 0. So what I look for is it's being raised to the power of 0. And as soon as I see that, I know my answer is 1. In our second example, we have 7 to the power of 0. Once again, as soon as I see that power of 0, I know my answer is 1. Here I've got 1 raised to the power of 0. Once again, since it's raised to the power of 0, the answer is 1. And in my final example here, I have 10 to the power of 0. Once again, as soon as I see the power of 0, I know my answer is 1. Our second fact says any base raised to the power of 1 returns the base. So, in general, if we have some number n being raised to the power of 1, then we get our number back. So if we look at our first example, it says 2 to the power of 1. Well, we know our rule says that if we take something to the power of 1, we just get our base back. So 2 to the power of 1 is 2. In our second example, we have 7 to the power of 1. Taking something to the power of 1 just returns the base, so we're going to get our 7 back. Taking 1 to the power of 1, once again it's going to return our base, which is 1, so our answer is 1. And 10 to the power of 1, since we take it to the power of 1, it's just going to return our base, which is 10. So our answer is 10. A couple other facts that we should know is that first, taking a base to the power of 2 is referred to as squaring the base. So if I see 3 to the power of 2, I can think of that as 3 squared. If I had 6 to the power of 2, that would be 6 squared. Also, taking a base to the power of 3 is referred to as cubing the base. So if I have 4 to the power of 3, I would say 4 cubed. And if I had, say, 7 to the power of 3, I would say 7 cubed. The last thing we want to talk about are exponents with a fraction base. Now, this is going to work the exact same way. And you'll notice that in each of our 3 examples, the fraction is in parentheses, and that's important. If we want the exponent to apply to the entire fraction and not just the numerator, then the fraction has to be an exponent. So all of our problems that we work with fractions, where we want to take it to a power, the fractions will be in parentheses. So we see this as 2/3 to the power of 2. And we know that this means that we want to take our base, which is 2/3, and multiply it by itself twice. So that's 2/3 times 2/3. Now, if our original fraction was fully reduced, then we're not going to have any reducing to do. So we just multiply straight across. 2 times 2 is 4. 3 times 3 is 9. The other way of thinking about it is that if you have a fractional base being raised to a power, the power applies to the numerator and the denominator. 2 to the power of 2 is 4, and 3 to the power of 2 is 9. In our second example, we have 3/5 raised to the power of 3. That's going to give us 3/5 times 3/5 times 3/5. Now we just multiply straight across. 3 times 3 is 9. 9 times 3 is 27. 5 times 5 is 25. And 25 times 5 is 125. So our final answer is 27 over 125. In our third and last example, we have 1/4 raised to the power of 5. That means we're going to have to multiply 1/4 by itself 5 times. So we've got 1/4 times 1/4 times 1/4 times 1/4 times 1/4. Well, the numerator is easy because 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1. We know that any time, it doesn't matter how many times we multiply 1 by itself, our answer is going to be 1. But the denominator is not going to be nearly as easy. It's going to start off not too bad. We've got 4 times 4, which is 16. And 16 times 4 we can do off to the side. So 16 times 4. That's going to be 6 times 4, which is 24. So we carry the 2. And then 1 times 4 is 4, plus 2 is 6. So that gives us 64. Now we have to do our 64 times 4. So we write 64 times 4. 4 times 4 is 16, carry the 1. And then 6 times 4 is 24, plus 1 is 25. So we get 256. And now we have to multiply by 4 one more time. So we take 256 times 4. 6 times 4 is 24, so we carry the 2. 5 times 4 is 20, plus 2 is 22, carry the 2. And then 2 times 4 is 8, plus 2 is 10. So we get 1,024. So 1/4 to the power of 5 is 1 over 1,024.